Good morning everyone. Myself Dr. N. Pratyusha, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today we will discuss the topic about the Fourier transform. It's a fourth topic in this Fourier transform. This is under numerical methods and integral transforms. Today's presentation overview was finite Fourier sine and cosine transforms, that formulas, and basic example about the finite Fourier sine and cosine transform. The formulas for finite Fourier sine transform and its inverse was the finite Fourier sine transform of f of x. Finite means it bounds between two limits. Means here I am taking 0 and L, means 0 to L. Here 0 less than x less than L is defined as fs of f of x equal to integral 0 to L f of x sine n pi x by L dx. For infinite transform, we will here integral 0 to infinity f of x sine px dx, right? Here in the place of p, I am taking n pi by L, and in the place of infinity, some finite element. Here I am taking L. L is nothing but anything like L is 1, 2, pi, 2 pi, anything. So if they have finite element is there, we will apply the finite Fourier transform. Okay. The inverse Fourier sine transform of function was f of x equal to 2 by L summation of n equal to 1 to infinity fs of n sine n pi x by L. Here fs of n is nothing but the finite Fourier sine transform. Similarly, for finite Fourier cosine transform, here in the place of sine, we will write cos. That means fc of f of x equal to integral 0 to L f of x cos n pi x by L dx. It will be represented as fc of n. The inverse Fourier cosine transform of a function is given as f of x equal to 2 by L summation n equal to 1 to infinity fc of n cos n pi x by L. We can, if it has an initial condition, we can write it as f of x equal to 1 by L fc of 0 plus 2 by L summation n equal to 1 to infinity fc of n cos n pi x by L. The finite Fourier sine cosine transform is nothing but the Fourier series. Only difference will be the L term. Okay. So these are the formulas for the finite Fourier sine transform and cosine transform and its inverse. Okay. We will go for the example. So here they given find the finite Fourier sine and cosine. Already I discussed in the previous session. For finite they will particularly ask finite. So here also they given find the finite Fourier sine and cosine transform of f of x. F of x is defined by f of x equal to 2x when 0 less than x less than 2 pi. It will be compared with 0 less than x less than L. That means here L equal to 2 pi. In the formula where the L is there, we can substitute 2 pi. Okay. So let f of x equal to 2x. So here we have to find both finite sine and cosine terms, right? So the finite Fourier sine transform of f of x is, what is the formula? So f of f s of f of x equal to integral 0 to L f of x. For sine you are writing that. So sine n pi x by L dx. This is the formula, right? So integral 0 to L f of x sine n pi x by L dx. So here in the place of x, f of x, we are substituting 2x, and in the place of L we will substitute 2 pi. substitute f of x equal to 2 pi and L equal to, f of x equal to 2x and L equal to 2 pi in the above formula, we get, so fs of f of x equal to integral 0 to 2 pi, what is f of x here? 2x, right? 2x into sine n pi x by 2 pi dx. This is right. So pi will be cancelled out. 2 is constant. So we will take it out. We get 2 into integral 0 to 2 pi x into sine nx by 2 dx. So here this is in the form of integral uv. Here u is x and v is sine nx by 2. What is the formula for integral uv? U into integral v dx minus integral d by dx of u integral v dx whole dx. This is the formula, right? In the place of u, x is there. In the place of v, sine nx is there. So we will substitute in the formula. We will get 2 into x is u, right? So x into integral sine nx by 2 dx minus integral d by dx of x is 1, right? So 1 into integral sine nx by 2 dx. Limits was 0 to 2 pi. So we will get 2 into x into integration of sine x is minus cos x, right? So in the place of x, nx by 2 is there. Nx by 2 is there. So we will get x into minus cos nx by 2 by n by 2. This is constant, right? So we will write in the denominator. Minus integral minus cos nx by 2 by n by 2 into dx. Limits 0 to 2 pi. So we will get 2 into minus 2x into cos nx by 2 by n, minus into minus plus, right? Cos x integration was sin x. Already means cos nx by 2 integration is sin n by nx by 2 by n by 2. Already n by 2 is there. So n by 2 whole square we will get. So sin nx by 2 by n by 2 whole square in the limits 0 to 2 pi. If you substitute 2 pi in the equation, we get 2 into minus 2 into 2 pi. In the place of x I am substituting, right? So 2 pi cos n into 2 pi by 2 by n plus, if you substitute 2 pi in this, we will get sin n into 2 pi by 2. 2 will be cancelled out. So sin n pi. Sin n pi value is 0. Sin 0 value is also 0. For the both limits, we will get this term was 0. So again I am explaining. Here sin nx by 2 is there. First we will apply upper limit, right? So sin n into 2 pi by 2. So 2 will be cancelled out, right? So sin n pi. Sin n pi value is 0. So when I apply sin in the place of x0, sin n 0 by 2 means sin 0 value is 0. For the both upper limit and lower limit, sin value is 0. So directly I am writing 0. So cos n pi value is, here 2 will be cancelled out. Cos n pi value is minus 1 whole power n, right? So 2 into 2 means 2 cube means 8. So we will get minus 8 pi cos n pi value is minus 1 whole power n by n. So we can write it as 8 pi by n into minus 1 whole power n plus 1. So this is minus 1, this is minus 1 whole power n, right? This is in the form of a power n into a power n. So we will write it as a power n plus n. So minus 1 whole power n plus 1. This term. Okay, this is f of x. Similarly, we have to find the finite Fourier cosine transforms also, right? So for finite Fourier cosine transform, the formula was f of x equal to integral 0 to L f of x cos n pi x by L dx. Here f of x is what? 2x, right? So f of x equal to 2x, L equal to 2 pi. Substitute in the formula, we get, here fc of f of x, right? So fc of f of x equal to, in the place of x, f of x, I am substituting 2x. In the place of L, I am substituting 2 pi. So I will get 0 to 2 pi 2x cos n pi x, n pi. In the place of L, 2 pi dx. So pi will be cancelled out. I will get 2 is constant. So it will be in out. So 2 into integral 0 to 2 pi x cos nx by 2 into dx. Again UV formula. So I will get 2 into x into integral cos, right? So integral cos, right? So cos integration was sin nx by 2. In the place of x, nx by 2 is there, right? So by n pi by n by 2 minus integral x differentiation was 1 and cos x integration was sin x. In the place of x, nx by 2 is there, right? So nx by 2 by n by 2 dx in the limits 0 to 2 pi. So again you have to integrate, right? So we will get 2 into x sin nx by 2 by n by 2 minus integral of sin x is minus cos x, right? Already minus is there. So minus into minus plus. So cos nx by 2 by n by 2 we will get, right? Already n by 2 is there. So n by 2 whole square limits 0 to 2 pi. So when we substitute 2 pi in the here, we get 0. For 0 also 0, right? So for both the limits we will get 0. So I am explaining here, sin nx by 2 is there. So when we substitute in the place of x 2 pi, so we will get sin n into 2 pi by 2. So 2 will be cancelled out. So we will get sin n pi. Sin n pi value is 0. For upper limit we are getting 0. For lower limit also sin n into 0 by 2. So anything into 0 is 0. That means sin 0. Sin 0 value is 0. It means for the both upper limit and lower limit we are getting the value as 0. That's why I am striking out and putting 0. So in the second limit 2 into cos n into 2 pi by 2 by n by 2 whole square minus cos n into 0 by 2 by n by 2 whole square. So 2 will be cancelled out. So cos n pi value is minus 1 whole power n, right? So I will get 2 into 4 by n by 2 whole square, we are common outing. So 4 by n square, cos n pi value is minus 1 whole power n cos 0 value is 1. So I will get FC of f of x equal to 8 by n square minus 1 whole power n minus 1. This is the result of the both finite Fourier sine transform and cosine transform. Here in the problem, they didn't give the deduction part. That's why we are not applying the inverse Fourier transform. Okay. First, we are taking the f of x function. Next, we will apply finite Fourier sine transform and finite Fourier cosine transform. And we will apply UV formula. Next, we will substitute the both upper limit and lower limit. We will get the result. Okay. This is the result of the finite Fourier sine and cosine transform. This is the finite Fourier sine transform result. This is the finite Fourier cosine transform result. Okay. In today's session, we will discuss about the finite Fourier sine transform formula, finite Fourier cosine transform formula. Based on this formula, we discussed about the example. Okay. This is the last topic of the Fourier transforms in unit 5 in the numerical integrals and Fourier transforms. Okay. Thank you.